Alright, welcome guys. I'm going to go over this entire logarithm homework with you. I'm hoping this is useful. I just want to make sure everyone understands it, and we're going to go through it. So the first 8 questions are kind of freebies, honestly. You just need to rewrite using our main logarithm rule. So as a reminder, what that main logarithm rule is, just so we can see it off to the side one more time, it says if I have b raised to the, which way did I say? Did I put x there or put y there? I think I put x there. Equals y, then log base b of y equals x. Some people like to call this the logarithm loop. The reason why is you could start with the b and raise it to the y power, and it will give you x. And this works the other way around too. If I start with that base of b, it'll give me x to y. There you go. Works the same way both times. So rewriting this very first one over here, this number 1, you could rewrite it as 13 squared equals 169. That's all they want you to do, because this is a true statement. 13 squared is 169, and log base 13 of 169 is 2. Same exact idea on literally every single one of these. Number 2, you're rewriting it. 8 raised to the negative 2 power is 1 over 64. Easy peasy. Number 3, 18 raised to the x power equals y. I'm doing the same thing over and over and over again. There's no differences here. Continuing on, number 4, it's all letters, and it's still the same thing. X to the z equals y, not exhibit. All right. Number 5, rewrite each in logarithmic form. You're going backwards. Going backwards here, it just means that log base x of 3 is y. Remember that all logarithms are exponents. In other words, this logarithm up here was an exponent. That's because it's an exponent of here. So this exponent here is going to be the answer to a log question. Number 6, same exact concept. Log base x of y is 17. I'm hoping you don't even need my help anymore on this next one. I'm just going to rewrite it right away. Log 1101 over 121 equals negative 2. And log 4 of 1 over 16 equals negative 2. Anyways, not too terrible for these guys. Oh, you can even see the right hand side of the paper. I apologize about that. So number 9, evaluate each expression. So if you have that long list of numbers straight up memorized, all these questions are easier. However, you're also allowed to use a calculator. So I'm going to show you the way to do it by hand and the way to do it on your calculator, because they're both actually kind of important. So number 9. So if you'd like to do this by hand, you could either be asking yourself the English question, 7 raised to which exponent is 343? That is what this question is asking. That's what log base 7 of 343 is asking. It's asking the exponent of 7 that gives you 343. 7 to what power is 343 is what that is asking. What is x? Well, hopefully you have that memorized. X is 3, because 7 cubed is 343. But if you don't have that memorized, you got to have that list of numbers, the huge list of numbers that we wrote out the other day, kind of in front of you. If you still need that list of numbers, please let me know. I can rewrite it for you. It's not that big a deal. You could also just play guess and check in your calculator. Sit over here in your calculator and do 7, times 7, times 7. Oh, that was 3 of them. There's 343. That's kind of a cheating method. It'll get you there. Number 10, same exact thing. Maybe you want to use the log loop instead of asking yourself this English question. If you want to use the log loop, just set it equal to x. That way you could rewrite it as 2 to the x equals 1 over 8. Solving it that way. The next step, rewriting that 8. I'm going to have to move up here because I'm running out of room. I didn't really write enough room for this question. So we could rewrite it as 2 to the x equals 1 over 2 cubed. How do I know it was 2 cubed? You want to have that same base just like we were doing in that previous lesson. 2 to the x equals 2 to the negative 3. That's our negative exponent rule, and therefore x is negative 3. But again, you could have asked yourself, 2 to what power is 1 over 8? Well, you got to know it's cubed, and it's negative in there because it's a fraction, so it gives you negative 3. Could have played a little bit of a guess around on the calculator. Now, numbers 11 and 12. Let's check this out. So here, we had 2 1/8, and you got a negative number, because when you have a fraction on the inside of this, you will usually have a negative answer. Not always, but usually. These questions, where the larger number is the base, you're almost always going to get a fractional answer. Let's talk about why we get a fractional answer. So let's say log base 81 is 27. Let's set this equal to x. Let's follow the same exact idea as this previous question over here. We're going to say 81 to the x equals 27. Hopefully you notice that both of these use 3 in some way, shape, or form. That list that we had the other day. Specifically, 3 to the 4th is 81, and 3 to the 3rd equals 27. And therefore, writing it 1 or 2 more times, 3 to the 4x equals 3 to the 3rd. Which means that 4x equals 3, and therefore x equals 3 over 4. But let's just say these fractions are not happening. It's not in your future. You don't want to do it. You don't care if a future class doesn't let you use a calculator, because I will let you use a calculator. There is a series of buttons that will let you follow through and get to the answer here. So let's check this out on the calculator. So what you can do on the calculator, ooh, I gotta zoom out just a little bit here. Let's zoom out. Nice. So zooming out there, on the calculator, if you hit the math button, scroll up to log base, it gives you this nice little thing where you can type in the answer exactly how you want it, log base 81 of 27. And then you want a fraction answer, because I don't want that decimal sometimes. We're going to hit math, and then enter, enter, and that'll give you that 3/4. You can do exactly the same thing on number 12, or you can kind of just do a little intuition here. It's saying 4 to what power is 2? Well, we know the square root of 4 is 2, so this guy must be 1/2. Hopefully that was easy enough. But number 13, 14, 15, it says use a calculator to approximate. That's literally all we have to do. The first one says log of 33. You literally hit the log button here, which means log base 10, by the way, and you hit 33, and you write the answer. It is free points. I just want to make sure that you actually are able to use a calculator accurately and round correctly. Same thing with this one. Where's this guy on the calculator? Number ln of 32. ln's literally right below log. As a reminder, that means log base e. We're going to have a whole lesson on it later. And that's going to give us 3.466. And number 15, I just taught you how to type that into your calculator. So typing this into the calculator, you'll hit math, you'll scroll up, you'll hit log base 3 of 23, and you get 2.854. For the rest of this thing, I'm not going to show you guys how to use the calculator. I'm going to assume that you can plug things into the calculator yourself. It's just hitting buttons. If you need help with the calculator, please come by after school. I'm available every day from 3:30 to 4:30. Except Fridays. I go home and sleep. Back to zooming in. Let's go back to number 16. We're already halfway through. 31 problems, with the first couple are so straightforward. Solve each equation, give both an exact and approximate answer. The approximate answer, this means calculator answer, which I'm not going to do on my video. You do need to practice doing that in the calculator. Make sure you're able to do it. If you only give the exact answer for the homework, life goes on, but on the test, make sure you're able to do it on the calculator. It is important. So this one, you just rewrite it using the logarithm loop. You write log base 18 of 5 equals m. This is the question. It is solved for m. That is the whole thing. You'll have to plug it into your calculator later. If you do it, you will get a decimal of some kind, point something. No idea what. Number 17. Same concept, we got to get p by itself. We have that exponent, we need to use logarithms to get there. So we're going to go ahead and rewrite this as log base 11 of 37 equals negative 8p. But this time we're not done yet because we haven't gotten p by itself. So we need to divide both sides by negative 8. So it's going to be log 11 of 37, all divided by negative 8 is equivalent to p. Simple enough. Let's move on to the next page. Number 18. So number 18 here, you got to do a little bit more switcheroo to really get to that logarithm situation, because the log situation doesn't work when there's this random plus 10 in there. So you actually need to subtract 10 first to do anything. So you get 2 to the n equals 54. So subtracted on both sides of the equation. You know what I'm going to do? I'm going to go ahead. That's not going to help us. I just don't like how the paper is like see-through right now. Oh well, whatever. Then we're going to go ahead and write log base 2 of 54 equals n, and that's it. Again, use that calculator when needed. If you plug it into your calculator, you will get an answer between 5 and 6, 5 point something. I don't know. Next one here. 9 to the n minus 8 equals 100. Why? We're adding that 4 to both sides. Don't randomly add the 8, by the way. That 8 is part of the exponent, so we don't want to move the 8 over. Just the 4. Now we're going to go ahead and do our log loop. Log base 9 of 100 equals n minus 8. Then we're going to add 8 to both sides of the equation. And that's it. Number 20. So number 20 is getting a little bit funkier. You again need to get everything to the log loop, but you can't do that with these multiplications and all this other stuff that's happening in the question. So you need to get it down to just a number raised to a power equals another number. So step 1 is to divide both sides by negative 7. This is a trick question. The reason why it's a trick question is you don't need logarithms. It looks like you do in the initial setup of the question, but once you've divided both sides by that negative 7, you get this thing where you have 4, which is the same thing as 4 to the 1, by the way, and therefore negative 8m minus 6 equals 1. Negative 8m equals 7, and m equals negative 7 over 8. So you actually don't need logarithms at all in this question. And if you did decide to use logarithms and use log base 4 of 4 in your calculator, log base 4 of 4 is 1. So you'd actually have to simplify that anyways if you did not notice that. So please be careful when you're doing these questions. Number 21. Step 1, add that 5 to both sides. 3 times 7 to the 6n minus 4 equals 7. We're just doing inverse operations. Divide both sides by 3. 7 to the 6n minus 4 equals 7 divided by 3. Use the log loop again. Log base 7 of 7/3 equals 6n minus 4. Add 4 to both sides. Log base 7 of 7 over 3 plus 4 equals 6n. And finally, divide everything by 6. I highly recommend plugging all of that into your calculator at least once to make sure that you can accurately get to the correct answer. And the correct answer, if you do it, oh boy, what will it be about? It'll be a fraction. What kind of fraction is it going to be? Fraction just barely less than 1. But we'll see. You guys have to try it out on your own, see if you can get to it. You know what? I'll type it out just this once, just to make sure you guys are able to do it. You're going to want to hit the alpha y equals enter to get a fraction bar. Got to hit the math button again. I'm going to scroll up to that log base. 7 of, and we want 7 divided by 3 here. Note how I didn't use alpha y equals enter there. You don't need to when it's inside the logarithm like that, unless you want to make yourself happy. There you go, like I said, a little bit less than 1. Approximately 0.739. Always 3 decimal places. Okay, number 22. So, concept here, number 22. We have 9, log 9 and log 9 on both sides, so there's not like a log loop per se to do, but because they're both logarithms on both sides, you can just forget about them and just write negative 3x minus 1 equals x plus 9. That's it. Don't have to do too much in terms of the thought process. Go ahead and add 3x to both sides, subtract 9 on both sides. We're going to get negative 10 is equivalent to positive 4x here, and negative 10 over 4 equals x, which does simplify to negative 5 over 2. There's my exact answer. And if you need an approximate answer at negative 2.5, it will work just fine. Solve each equation in big all caps I have written. Remember that the inside of logarithms can't be negative. The reason why I wrote that is there's going to be 2 answers to this question, but one of them is not going to work. So you have the log on both sides. Again, they just cancel out right away. And now all of a sudden we're going back to semester 1 for a second, because you have to know how to solve something with x squared in it. How do you solve something with x squared in it? You can factor, you can use quadratic formula. You have a lot of options here. I think the easiest way here is going to go ahead and add 2x to both sides and add 1 to both sides to get x squared plus 2x plus 5. Pause, let you think about it for a second. And if that's the case, now we have to try to factor. Unfortunately, nothing is going to multiply to 5, but adds a positive 2. So we need to immediately use our quadratic formula. But now I'm thinking about it, is there even an answer to this problem? Did I make a mistake? X squared, oh my gosh, I can't do basic math. This is a minus 4. I am so cut from the team. That is not a plus 5. Now here I am doing this problem in pen, and I'm not even doing it right. Negative 2x minus 1 equals x squared. I'm just copying the whole thing again. Minus 4. I'm adding 2x minus 1 to both sides, so I'll get 0 equals x squared plus 2x minus 3. Okay, now we have something to work with, because this is going to factor. So factoring right away, what multiplies to negative 3 and adds to positive 2? We're going to go ahead and get x plus 3 multiplied by x minus 1. Don't forget this still equals 0, and therefore x equals negative 3 and x equals 1. However, what I mentioned at the start, if I plug negative 3 back into this, well, that's going to be 6 minus 1, that's 5, so that's fine. Negative 3 squared is 9, minus 4 is 5, that's fine, so this is an answer. But if I plug 1 back in, I get negative 2 minus 1, that's negative 1. You cannot have logarithms negative, so right away, this is not a solution. It does not work, only negative 3 works. So you can't write both answers. Be careful with that. Number 24. Now it's the same concept, but backwards. Now the answers are in the inside. So we're going to first do our log loop. We're going to write 3 squared equals b, and if you don't know that that's 9, don't know what to tell you. Use your calculator, I suppose. Continuing on, same exact idea in the next one. We got 5 to the negative 1 equals 5n. So how do I write an exact answer to this question? Well, the 5 to the negative 1, that's the same thing as 1 over 5 equals 5n. Divide both sides by 5. Remember that dividing both sides is like multiplying by a fifth. 1 over 25 equals n. Your other option is to use your calculator's fraction button to make sure that you've got it out. So you could type in simply the original problem up here, the 5, raise it to the negative 1 power, and then divide both sides by 5, and get 0.04. Hit math, enter, hit math, enter, enter, and it will give you that 1 over 25. That's another option. Let's go on to the next page. The last page that we have to do. So, number 26. So to solve this question, you can't use the log loop until the logarithm is by itself. So I first need to divide both sides of the equation by 2. 4 divided by 2. I didn't subtract 2, by the way. I divided by 2. I don't like how this didn't put parentheses around my x, so I'm going to put parentheses around it. You have to remember, if there's not a number written here, it's implied that it's a 10. So we're going to write 10 to the 2 equals x, and again, I really hope you know that's 100. Continuing on, same idea. I don't like how there's not parentheses, so I'm putting them in. After that, add 3 to both sides of the equation. Use your exponent rules. 11 raised to the 2 equals negative 2p. And therefore, 121 is negative 2p. Divide both sides by negative 2. You get negative 121 over 2 equals p. A little bit weird, but not the end of the world. Let's continue. So, number 28. Gotta subtract 7 first. Same concept as that last page. I gotta have that number by itself to actually do this problem. Then we got 5 raised to the 4th power equals negative 4n minus 9. Like I said the other day, if you have that whole list of numbers memorized, these problems are easier because I don't have to go to my calculator and start writing 5 to the 4th. I can just know, yeah, that's 625. I know that. You can go ahead and add 9 to both sides of the equation and get 634 equals negative 4n. And therefore, writing it, we'd have n equals 634 over negative 4, which will reduce. What does that reduce to? It reduces to 317 over negative 2, which does not reduce anymore. Finishing it up, we don't have much more to do. Add 3 to both sides first. 5 times log base 2 x minus 2 equals 15. Divide both sides by 5. Log base 2 of x minus 2 equals 3. Rearrange using that logarithm loop. 2 to the 3rd power equals x minus 2. 8 equals x minus 2. Add 2 to both sides. 10 equals x. Let's continue. Moving on to over here, we got 4 log 5 10n minus 4 equals 4. Divide both sides by 4. Log base 5 10n minus 4 equals 1. 5 to the 1 power equals 10n minus 4. I don't know if you guys saw that, but my brain like short-circuited for a second. Like I just stopped thinking. I like dazed out. I don't know. It's getting late. 2 more problems. Let's do them out. So 5 to the 1's 5. Adding 4 is 9. 9 equals 10n, and therefore 9 over 10 equals n. Explain why you don't necessarily need logarithms to solve this equation, then solve how you'd like it. You don't need logarithms. Oh my gosh. You couldn't even see the rest of that problem. I'm so sorry. That's where my brain's at right now. It's just gone. It's exiting the building. It's going to bed. It's 10:41. I need to sleep. Okay, we got 6 to the negative 2b equals 216. So we don't need logarithms here because both sides can be rewritten as a power of 6. That guy's 6 cubes. So that means right away I can just write negative 2b equals 3, and therefore b equals negative 3 over 2. That's by far the easiest way. You don't need to use a logarithm loop to solve that problem. It'll take you way too long to do that. That's it. Noticing this, there's a practice problem in here that I didn't see done, so I want to go back over it from earlier in the packet. I do want to go to bed, but at the same time I want to make sure that we know how to do these problems. So I'm going to do these 2 practice problems here. You should have had to do these in class, but if you didn't get them done in class, there's a chance to get them done now and maybe re-understand them because they will be on the test or the quiz. So what do we got to do? X to the 3rd equals 7. This is a log loop. How do I solve this equation? You got to raise both sides to the 1/3 power. The concept is if I raise both sides to the 1/3 power, x 3 to the 1/3, 3 times 1/3 is 1. That will cancel out completely, and I'll just get x to the 7 1/3. I could just plug that into my calculator and just circle it because that actually is an exact answer. Same concept with problem number 4. I could rewrite this as x raised to the 4/5 equals 1/2. There's my log loop. Raise both sides to the power of 5 over 4, and I'll end up with x equals 1/2 to the 5 over 4. You might want to practice plugging that into the calculator. If you do, you will get approximately, I just remember from class time, that's 420. Nice. Have a great rest of your day. Good luck finishing this homework. Hopefully it was useful. Good luck on the test or quiz coming up, and have a good one.